Hello, everyone, and welcome to this Mobile World Live webinar. I'm Diana Guverts, Mobile World Live's U.S. editor, and I am pleased to be your moderator for this event. Today, we're going to explore the topic of private LTE and the benefits that this Wi-Fi alternative can offer for enterprises. Compared to traditional Wi-Fi connectivity, private LTE offers enterprises access to a more secure, scalable, and resilient network. Private LTE is also equipped for the challenge as companies look for ways to support new IoT applications and reliably process higher volumes of data with lower latency. There are a number of different ways to set up private LTE networks, for instance, using licensed, unlicensed, or shared spectrum, each of which offers its own benefits depending on the use case. Here to walk us through all the ins and outs of it all are Safi Khan, who is Telit's Regional Product Marketing Director, and Robin Duke-Woolley, who is CEO of Beecham Research. Welcome, Safi and Robin.
Great to be here.
Hi, everyone. This is Safi.
So before we get started, I'd like to encourage our audience to engage with us by posting comments and questions. I can see that some of you have already found it. At the bottom, you can submit questions in the webinar window by typing into the comment box underneath the slide. And at the end of the presentation, we'll take some time to answer your questions. With that, I will go ahead and hand things over to Robin. Robin, if you want to go ahead and get started.
Thanks very much, Diana. Yes, okay, so we'll move to my first slide. Okay, just to start things off, so Beecham Research has recently conducted a study in this area. A report will be out shortly. And we use, as the basis for that, a model of the public cellular IoT market and the connectivity there. So that's the basis of our forecast model. So it's an interesting place to start this presentation. This chart shows cellular IoT market growth over the next few years. This is for public LTE networks. The overall growth, compound annual growth rate, is greater than 30% per annum. But that hides quite a lot that's going on under the surface. So we split it into three levels. High bandwidth, which is 4G and 5G. Legacy, which is 2G, 3G. And low bandwidth, NB-IoT and LTE-M. The high bandwidth has a high growth rate. The legacy is pretty flat. We see the whole thing changing, moving over to LTE and 5G, and 2G and 3G no longer really relevant as growth in this marketplace. And then high growth also in low bandwidth, NB-IoT and LTE-M. What that means is that LTE technology as a whole is mature, it's flexible, it's reducing in cost, and that means that more applications in the IoT space become possible to use LTE technology over time. And that means quite a lot when it comes to private networking. So moving to our next slide is this is on-site use of connectivity technologies. This is part of the study that we did. It was our own survey of enterprise users, and it was specifically related to use of IoT. And the question was, what kinds of connectivity technologies do you use on site? There's unlicensed technologies like Sigfox and LoRa, Bluetooth, bit of a wild card, if you like, because it's obviously very short-range stuff, but people felt that it was necessary to tick that one. But the real point of the chart is Wi-Fi and cellular. So Wi-Fi is obviously specifically on-site use. Cellular is more likely at this stage to be wide area use rather than private networking use. And you can see that Wi-Fi for IoT applications is very high as a percentage, by far the greatest penetration on site. But there are some problems associated with that. which are quite well known, but we were measuring them as well. For on-site use of Wi-Fi, some of the questions that we asked were related to issues arising with Wi-Fi. One of them being, does it need to operate outdoors in your particular installation? 59% said that it did. If so, does that present difficulties? 56% of those 59% said that it did present difficulties. Does it need to connect with moving vehicles? 63% said that it did. Of those, does it sometimes lose a connection? 94% said that it did. This is not surprising because Wi-Fi is not really set up for mobile use. It's much more for static use, much more, frankly, for office and administrative use than for industrial use. Do you consider it to be secure? 70% felt that it was. Are there blind spots on the site? Over 50%, 54% said that there were definitely blind spots on the site. And this is something that increases as a problem the larger the site, because it's not just quite difficult to cover a full site using Wi-Fi. It can also be quite expensive because you need quite a lot of access points to be able to, or nodes, to be able to cover a very large site. And then you've got to find some way of syncing those so that when things do move from one to another, you don't get multiples. Are there interference problems? 50% felt that there were interference problems. So just to sort of summarize that, Wi-Fi is the first choice for on-site IoT applications. But as IoT use becomes more central, more important, more business critical, Wi-Fi limitations are becoming clearer. And examples are, as I say, operating out of doors and full site coverage, but also moving devices, and that could be, or moving assets, that could be containers, it could be even hospital beds. Certainly some problems in hospitals in moving highly connected hospital beds from one part of a hospital to another. And IoT use, as that continues to grow within the enterprise, I think it's becoming very clear that it can no longer rely so heavily on Wi-Fi. It is a constraint in the growth of enterprise IoT. So, things need to happen, really. It's not possible to stay just with the existing technologies as we move forward. So looking then at why private networks for enterprise IoT. So stepping back from it a bit. Now, Safi is going to say a bit more about this as well, but picking up some points that to emphasize the technology differences. The small cell market has been operating for many years, but it's been primarily voice orientated. There's been use of 2G and 3G, but that's not optimal for IoT. Whereas LTE is well suited to IoT, as I explained in the opening slide. So LTE introduces high bandwidth and a narrow band. And that means more applications can be served. And the ROI for licensed LTE, in fact, usually requires voice to be included. It's much more the case that for a licensed private LTE use, there's the cost of a license fee itself, the cost of the airtime. So it's normal to put all the traffic through it to justify that cost, and that includes then the voice as well as the data. So it's a more complete solution, if you like. There are, for private networking, licensed and unlicensed spectrum options, as Diane just mentioned. Also, for private use, there's much more of an emphasis on CapEx as opposed to OpEx, so capital expenditure as opposed to operational costs, which means less in the area of MNO subscriptions. Local management control is very important. It means less or no dependence on third parties. The data remains on-premise, which is becoming very important, particularly for real-time information. And local coverage, as I mentioned in the last slide, local coverage designed to meet on-site needs, no blank spots. And then finally, security, and I think Safi's going to talk more about this. Security for on-site is always an issue, and security generally is one of the most concerning areas of IoT solutions now. Anyway, so it's obviously a key concern. But private networking has a different emphasis on security compared with a public network. So then moving on to typical sites for a private networking activity. These are the ones that we have looked at as part of our study to look at how many of them are there in the world and which are most likely to need private networking. There's 12 areas there, so mining, large retail, events, sites, stadia, oil and gas, military bases, power generation, transport venues, airports and ports, hospital and labs, quarries, water utilities, university campuses, warehouses, industrial and manufacturing, and just a couple of examples there of shopping malls, airports, ports and warehouses. The point that I would make here is that although some of the unlicensed technologies that are becoming available now, or unlicensed bands that are becoming available now, such as CBRS, focus more on broadband, that it does not mean that there is not a requirement for narrowband as well. And we see that the whole site requirement, there is a mixture of high bandwidth and low bandwidth applications that need to be catered for. And that's what private LTE needs to focus on. So some of these things, particularly like all of those sites, in fact, airports, ports, warehouses, shopping malls, and the rest, it becomes quite easy to see that some of these become very large, and to have or the ability to cover these with just a Wi-Fi type of experience becomes quite difficult. You can end up with over 100 access points quite easily with Wi-Fi, and then there's the difficulty of coordinating all of those. The point about using LTE is that you can use about 1/10 of the access points, and so it's much more efficient, and it caters for much more for moving objects and so forth. So quite a lot of opportunities like that. An area that I haven't included in this is first responders, which is FirstNet and others, and we can cover that later. So the next, if you like, dimension of this is public-private roaming. So there are public networks that can be used for private network use with local radio access networks to provide for that, and then local EPCs or EPCs relating to or attached to the public network to cover the local traffic or the local requirements, the local administration requirements. Then there's completely private or separate private networks, and that could typically be in a remote area where there is no possibility of using a public network and segmenting a public network. And then there's the need, though, to provide potentially interoperation between the two. That would be via some sort of EPC development. And that would typically be used in ports, in mining operations, in airports, and so forth. And what that means is that, say, a truck that is connected through a private network when it's on site, when it goes outside the bounds of that private network, it then connects to a public network, and then it's sending data back through the public network than through the private network, and it's all ending up in the right place. To do that efficiently is not a particularly easy task, and there are specialists in EPC developments that assist in that kind of activity. So it's another dimension to need to take into account for private networks. Okay, so if we then move on to frequency allocations, now this again is something that Safi, I think, is going to talk about in more depth. But the point about this is spectrum is in high demand, basically. So finding available spectrum for this growing requirement is quite hard because obviously we all want our smartphones. They're all connected to networks, and there is a strong emphasis in trying to free up spectrum just for that use, let alone for specific business use. So in addition to the licensed spectrum that's available and becoming available, there is a great search for unlicensed spectrum that could also be used for elements of private networking. There's a need to free up spectrum for new uses, and then there's going to be a number of local variations, if you like, in different regions, because this is not all controlled internationally; it's all controlled nationally and regionally. So what's right for the U.S. market may not be right for, and it isn't right, in fact, for the European market and the Japanese market and so forth. So it all varies, and then the devices themselves have to cater for that. So you end up with smartphones, for example, having up to 28 different bands that they can access to be able to roam between different parts of the world. We don't see any of that. That's all hidden from us when we're using these things, but that's all adds to the complication of using it. So I'm not going to talk any more about that. And also the next slide is specifically about CBRS so Citizens Broadband Radio Services, specifically for the US market. It's currently used primarily by the US Navy for coastal offshore use, but that uses only about 1% of the spectrum available in the 3.5 gigahertz band. So to make greater use of it, the CBRS Alliance has become involved, uses the name OnGo for wireless services in this band, and there is a three-tier concept has developed, which partly includes unlicensed spectrum, which then makes it possible to use particularly high bandwidth devices for on-site use, and to grow that market, and therefore have an alternative, if you like, for Wi-Fi. So I'm not going to say any more about that because, as I say, Safi is going to go into that in a bit more depth. I will say a few words about multifier. Multifier is another umbrella specification that has been developing. It looks like that title is actually misspelt. It should be MULTE and then a capital FIRE. The multifier specification, I think, was launched in 2017. Trials started then. The initial market launch was actually at 1.9 gigahertz in Japan, but that was for a very small spectrum allocation that hopefully will now increase. So that was the start of it in the marketplace. But most of the trials and most of the work has been going at the 5 gigahertz, which is the Wi-Fi band. But nothing's been launched yet in that area. It's taking a long time to actually get that out into the marketplace. So it's taken longer than expected to get it out. but the opportunity is great once it does come out because it's, as I say, it's an umbrella specification that covers a wide range of, or potentially a wide range of different frequency bands from about 900 megahertz up to 5 gigahertz and beyond. So there's lots of stuff in that area. But this is unlicensed use, not licensed use. And that leads me on to my final slide, which is what does that mean in terms of business potential? Well, from the work that we've done, we believe that the private LTE for enterprise IoT, not the private LTE for voice and stuff like that, but for enterprise IoT, we would expect it to be worth over $30 billion revenue by 2025. Particularly attractive for large sites, but increasingly attractive for medium sites and maybe even small sites as well, particularly for in the unlicensed spectrum areas. As I say, for the licensed spectrum areas, there's additional costs because the bandwidth has to be paid for, the spectrum has to be paid for. So that's causes more cost. Private LTE requires higher concentration of gateways and routers tracked to cellular broadband growth. So we see a high growth in gateways and routers market for this sort of use, and we think it's going to become a significant element of the enterprise IoT market. Higher concentration of cellular modules, and we think that will cover both broadband and narrowband. So it's potentially a high use of narrowband is in prospect for that as well over the next few years. When I say the next few years, I mean the period up to 2025. With that, I'm going to hand over to Safi Khan at Telit for the next part of this presentation. Over to you, Safi.
Thank you very much, Robin, and hello again, everyone, for those who joined later. My name is Safi Khan. I'm a Regional Product Marketing Director with Telit, and today I'm here to talk about private LTE. So let's get started. Okay, so what is private LTE? Why is it important? So let's talk about that. A private LTE, as some of you may already know, but this is training for those who may not know. But it's a dedicated network for an enterprise, which is physically separated from the wide area macro network like your Sprint or Verizon or AT&T T-Mobile network. So a private network is dedicated and it's separated, and it's used for specific IoT applications, services, and it targets specific verticals like Robin already mentioned: mining, industrial manufacturing, automotive manufacturing, utility metering, logistics, hubs, transportation hubs, smart cities, drones, hospitals, enterprises, campuses, stadiums, etc., etc. So there's a long list of use cases where private LTE networks equally apply. It can be operated by a mobile operator or by a private company. So even the mobile network operators are very, very interested in the spectrum offered by private LTE networks, mainly to increase capacity and add more carrier aggregation channels. And as already mentioned, it can operate on licensed spectrum or unlicensed spectrum and shared spectrum. So I will cover these in more detail because there's lots of interest in unlicensed and shared spectrum, especially because of the lower cost. Private 5G is a natural evolution from private LTE, so it's also coming. Private LTE is already taking off commercially, but private 5G is hot on its heels. It's right behind private LTE. So in essence, private LTE is laying the foundation for private 5G, and you'll get all the benefits of 5G for all the verticals mentioned before, especially the ultra-low latency and high reliability of 5G, specifically suited for industrial and manufacturing settings. So let's talk about these 4 main points that covered in this slide here. So security, number one. So we've all heard the stories of Wi-Fi hacking, right? How hackers can find ways to break into Wi-Fi networks by exploiting vulnerabilities. So it's widely known that Wi-Fi is hackable and not secure. So especially that's concerning for enterprise customers who want to protect their data. There was a famous example where a casino in Las Vegas, for example, was hacked. And the way these were Russian hackers, very smart, the way they hacked was that they got into the casino's network by hacking into a Wi-Fi thermostat, which was in a fish tank. So imagine in Vegas, you're roaming around in a casino, they have these fancy fish tanks, but they have a Wi-Fi thermostat, which is vulnerable. And this is what was exploited, and that's how they got access to the casino's network. And so the enterprises want to protect their data, and they see LTE as a more secure end-to-end cellular connectivity technology that has enterprise-level security. So when these enterprises and industrial manufacturing complexes, city infrastructure, want to upgrade their security, they look towards cellular LTE, and they want that higher level of security. But public LTE carrier networks cost higher than Wi-Fi. So Wi-Fi is very attractive in terms of low cost. So they are looking for lower cost alternatives, and that's where private LTE brings them the best of both. It brings the security of LTE at the price points which are now going to be comparable to Wi-Fi because the spectrum is shared and unlicensed. Private 5G will also offer similar benefits for enterprises and industrial sectors. So that's very important. The second one is latency. In private LTE and private 5G both, the data is not going all the way back to a core network in a carrier's network and coming back. It stays on premises. So this is one of the advantages of private networks, where the end-to-end latency can be more tightly controlled. Low latency is particularly well suited for smart manufacturing. And many industrial manufacturing conglomerates are trying to replace wires. They want to replace the wires with wireless, but they want it to be low latency. So, for example, an emergency stop button can be operated with wireline level reliability. And so most factories are replacing cables with wireless, and this private LTE and especially private 5G, which is coming afterwards, are just bring the right combination of features to make these things very attractive for many of these sectors. Connectivity is obviously bread and butter. The connectivity that we have today from LTE has spawned so many innovations. We are seeing strong interest in moving the legacy LAN, mobile radio, telephony, and all the legacy systems to modern LTE systems. And they want to include voice over IP, voice over LTE, called VoLTE. So public safety, first responders, they're all looking at private LTE offerings as a means to reduce their operating costs. And also the mix of bringing indoor and outdoor operation in these scenarios is more suitable for LTE as compared to Wi-Fi, because Wi-Fi performance in outdoor in terms of range and performance is not as well suited as the LTE is suited. So there are all these reasons why we are talking about private LTE, and there is so much interest. And specifically in North America, that we're going to target the CBRS bandwidth available in the U.S. Band 48 specifically has plenty of bandwidth available for basically operating these wireless technologies. So obviously spectrum is at the heart of these cellular technologies. So this map is showing some of the major private LTE spectrum bands and usage around the world. But today we want to focus on North America, where FCC and the CBRS Alliance, they have worked very hard to bring CBRS band 48 into a commercial reality. That's basically 3.5, 3.7, and 3.8 gigahertz bands. And they're far ahead of other regions in terms of commercial network deployments. The U.S. also has band 53 owned by Globalstar, which is also very attractive spectrum for private LTE. Unfortunately, chipset providers have not yet added support for band 53, so we are waiting for it to be supported. Band 42 and 43 are essentially overlapping band 48, and these are two bands available globally, for example, in LATAM, Europe, Australia. So we also support band 42 and 43, and Europe, for example, is using 42 and 43. So this is not an exhaustive list. This is some of the major spectrum usage that we are seeing, but there are many others. And so it's still, spectrum auctions, and governments are still opening up more and more spectrum. For example, UK is trying to follow the US example of shared spectrum. They plan to open up spectrum in 3.8 to 4.2 gigahertz, as well as 1.8 to 2.3 gigahertz. Germany, for example, of course, all the auto manufacturers from Germany, the government of Germany is offering them special program to operate a private LTE networks in band 42 and 43. And the use cases are very interesting. Auto manufacturers all across Europe, they love private LTE, mainly because of the reasons covered previously, like security, low latency, robust connectivity in a factory setting. It's a very noisy environment. You want very reliable tools. And so they're equipping, for example, their shop tools, like handheld tools used by the factory personnel, to be LTE enabled for connectivity, so that they can leverage all the smart manufacturing practices and so on. So next, I want to touch on the nuts and bolts of the CBRS on-go. Some of it was already touched upon by Robin. So let me just expand on that a little bit. So let's try to understand how private LTE networks work. So we are looking at the on-go service by the CBRS Alliance in North America as an example of a private LTE network. So a private LTE network can be formed as long as it's abiding by the 3GPP and the IEEE and the FCC rules and GCF and PTCRB. So as long as all the regulatory is abided by, any private LTE network can be created. So one example of that is the CBRS network in the US, operating in band 48, and under the umbrella of the CBRS Alliance, and branded as the on-go network. So let's start with some acronyms that you will hear. CBRS, as some of you may not know, stands for Citizens Band Radio Service. So this is an alliance of companies that is working to define the rules that make the use of shared spectrum more efficient and functional. The way the system works is that there are multiple users of the spectrum, and some have higher priority over others. For example, the U.S. Navy operates radars in the same spectrum, mostly along the coastline. So CBRS Alliance defined an entity called the ESC and SAS. So ESC stands for Environmental Sensing Capability. These are sensors that detect, like when the Navy radar is on, they send this information to the SAS, which stands for Spectrum Access System. The SAS then looks at all the users on the private LTE network and tells them to turn off when it receives the signal from the ESC, telling the SAS that the Navy radar is on. And the SAS also manages the priority of two other layers of users, which are the PAL users and GAA users. PAL stands for Priority Access Licenses, and GAA stands for General Authorized Access. So the SAS manages the priority between PAL and GAA if the Navy radar is off. Now, PAL users have paid for a license, although this licensing fee is far less than what carriers pay, for example, for their fully licensed spectrum. So PAL users get priority over the GAA users. GAA users essentially use the spectrum at almost free cost, except for the cost for the SaaS service itself. And so this GAA access, and also even the PAL, is the most attractive aspect of private LTE networks. And as mentioned earlier, many industry verticals that were using Wi-Fi and other legacy technologies are interested in private LTE networks to bring their systems up to the latest technology and also to future-proof their systems. They want to adopt the fastest growing connectivity technology like LTE and also get ready for 5G. So now let's look at the different components that are talking to the SaaS server. So the infrastructure devices are called CBSD or CBRS devices. These are similar to small cells in a public LTE network. And there's a class A for low power indoor use and a class B for outdoor higher power use. Remember we talked about outdoor advantages that LTE has over Wi-Fi. So these class B base stations are what make private LTE attractive for large venues like mining, agriculture, logistics, or transport hubs, train stations, airports, etc. They can get much more range and outdoor performance. So an entire private LTE network can be realized with these components. They can essentially all fit in a network closet on premises. So the idea is very secure. Your data doesn't leave the premises to go to a public network and come back. It never leaves the premises, so it's more secure. And this aspect of security is very important for enterprise level use cases, like I mentioned before. Now on the right, we show two scenarios for private LTE networks. One on the top is a self-contained private LTE network. And this could be for a particular venue, like industrial setting or logistics hub for transport, or a sports or concert venue where there's heavy data usage, or simply an office or enterprise setting or an MDU, like a multi-dwelling unit, like apartment buildings. So we are seeing strong demand for private LTE networks in all these scenarios to offer fixed wireless access as the first big use case for private LTE network, especially indoor coverage, cellular coverage, which is the second option on the bottom. So a company like a neutral host can provide cellular coverage for both private and public LTE networks. Now, this model of a service provider works well if the network operators, for example, want to extend their coverage into specific venues like stadiums or airports or enterprise buildings like hospitals, etc. You know, you've all experienced that parking garage where your cell phone doesn't work, or if you go in the lower levels of a stadium, you can't connect. So these neutral hosts can actually augment the cellular carriers by offering a service to them. And they may not have invested in indoor coverage in these venues because they're too small for the large operators. So that makes the room for these private enterprises to play in this space. And we're seeing a lot of activity there. A quick look at the ecosystem of the private LTE space. Again, this is a list of the main players in these segments, and by no means it's a complete or exhaustive list of companies. The actual ecosystem is very large, and there are many companies involved in making private LTE become a reality. What we want to show is, from a high-level view, where do major industry players sit? So as I explained before, the CBRS on-go private LTE network service must have the ESC and SAS components to be able to use the shared spectrum in band 48. So there are three major players who have a license to operate these SAS networks. So CommScope, which is also Ruckus and Aris combined, Federated Wireless, and Google. So these companies have installed their environment sensing equipment on the coastal United States, and they operate the SAS servers to manage the devices. Next, there are companies like Expeto and Cellular who are working on an end-to-end networking stack for private LTE, private 5G. Now, of course, there is an overlap in these layers. So some of the players above and below, like Nokia, Ericsson, Ruckus, as well as CommScope and Federated, they also provide their own networking stack. And there's a lot of room for innovation in this layer. For example, latency reduction, security enhancements, network edge processing, network slicing. All these things can be innovated on software through these networking stacks. Infrastructure equipment providers, the traditional Nokia, Ericsson, Ruckus, they're providing the small cells, the antennas, the base stations, EPC core networks. So these solutions are basically the same equipment that's used in public LTE networks, but repurposed and scaled down for use in band 48 and for smaller size deployments. Next, the system integrators that are providing an end-to-end system to the end users of private LTE networks. Companies like American Tower is one of the major players in this space. The end user devices and enterprise routers and gateways in this space. So there are basically companies that offer the routers and gateways that provide the service to the end user. For example, you and me, like if we have our smartphone, so all the major smartphone providers, Apple, Samsung, Google, they all have included band 48 support in their products. So along with this frequency support, there's also the need for dual SIM support, so they can have one physical SIM and one embedded SIM. And that way the phone can roam between the private LTE network and the public LTE network in the roaming scenario. And then the gateway and router providers are basically using an embedded LTE module, and that's where Telit plays. So we play in the module space, which is providing the LTE modules that support the private LTE band. I will cover those in another slide coming. So I think Robin already covered a lot of the use cases for private LTE, but I just wanted to kind of add a little more flavor in terms of industry segments, which are basically evaluating private LTE and 5G networks. So in these verticals that you see here, it's basically the last two columns are of interest. There's a typical size of the network and the number of networks delivered by, let's say, 2023. So there are cases like public safety where the individual size of the network is very large, but there are fewer of them. And then on the other spectrum, like manufacturing, the size of the network could be small, just a factory, but there are so many of them, so there are high number of these networks. And then on the left, we've tried to give you some kind of mapping on what the module category would be required in these scenarios. So, you know, these are basically category 4, 6, 12, 18, for example. Cameras, you know, with the video tend to use the highest data rates. And so Cat 18, 1.2 gigabits per second would be useful in that scenario. You know, down to like, you know, trackers and telematics and IoT sensors, which could be happy with Cat 4, Cat 6 down. So there's a range of LTE categories for UE, which are deployable for private LTE networks. So all these different segments can leverage the different module categories. All right, and this will be my last slide before we switch to the Q&A. So just wanted to briefly show you what LTE modules we are working on and what we have. So as you know, Telit is a leader in enterprise cellular modules. Our flagship module is the LM960A18, the one on the left. It's in full production now, and it's the industry's first gigabit LTE module, which is certified for all the major carriers in North America and as well as globally. And it's based on Qualcomm's Snapdragon SXS SDX20 modem, and also supports CBRS band 48 and other private LTE bands like band 42, 43. It's a single global SKU, and it includes embedded GNSS for location. So we are engaged with several partners who are developing CBRS products for private LTE, such as routers, gateways, fixed wireless equipment. And also, this module has won several industry awards and particularly suitable for enterprise customers and industrial customers because it's built with the highest manufacturing standards. And so it's in full production now and available in a mini PCIe form factor. The next module that we are bringing to market is coming in the first half of next year, 2020. And this is a CBRS-only variant of the LM960A18 that I just explained. So by having a CBRS-only variant, we are able to optimize the features specifically for private LTE networks. So it will support band 42, 43, 48. It can go up to 450 megabits per second and still has the embedded GNSS. It will serve all those various market verticals that we talked about where there is no need for a public LTE network, like a local deployment in an enterprise or venue or industrial setting. So there can just be the whole network and then one single point in the network where access to the outside world is provided through a firewall and in a controlled manner. And so in this scenario, all the data stays on premises and more secure. So we are very excited to be offering these modules to the industry. We want to help propel the private LTE networks into full commercial scale as quickly as possible, as well as be ready for private 5G coming right after private LTE. So thank you very much, and back to you, Diana.
Great. Thank you guys for an awesome presentation. So that concludes the presentation part of this webinar and takes us on to the question and answer portion. Now, before we get started, I just wanted to let everyone know there's still time to ask your questions. Just go ahead and type into the comment box beneath the presentation window to submit your questions. We're going to get to as many as we can. And before we get started, I also want to reassure you that, yes, we will have a replay of this made available afterwards, as well as the slides, so you can catch up in case you missed anything from the start. And with that, we are going to go ahead and get to this flood of questions that we have, starting. I'm seeing a couple questions on ROI. So I'm not sure who wants to address this, but how do you justify the ROI for private LTE deployments in specific industries? We had one commenter ask about mining oil and gas, as well as another who asked about retail and shopping malls. So if you could address that and maybe talk about some of the main KPIs.
Well, I could start that off. The ROI does need to take into account all of the uses, and I mean what we're finding is that depending on whether there is a use, as I said in my presentation, whether there is a use of spectrum that is licensed or not, does make a significant difference. So if it's unlicensed, then there is no cost for that, and then the ROI is all to do with the return for the particular application. And CBRS is focused at the moment primarily on broadband, so that's the ROI for that can be quickly proven. Because it's a high return for broadband applications. For licensed, it's not more problematic. It's just a little bit more complex. So there is a need to understand what the cost of the spectrum will be, and then factor that in. As I said in my presentation, this is often done in remote sites, so mining, oil and gas, so forth, where there is no other infrastructure to use, and there these tend to be very large sites, and they use the spectrum for all traffic, voice as well as IoT and other administrative data and so forth. And I think it's fair to say that in those kinds of situations, it's not usually appropriate or not possible, should we say, to get a good ROI for just IoT applications. You need to bring in the other traffic as well. So the ROI calculation is very different for licensed versus unlicensed, and depends on the types of applications that are going to be used as well. There's a lot more detail there, but I think that's appropriate for now. Safi, I don't know if you want to add to that.
Yes, thanks, Robin. Someone had mentioned in the question that Diana repeated about mining. So, just to clarify, for example, if you're in a remote mining area, a mobile network operator may never have cellular coverage there because it's not worthwhile for them to go and invest in a remote site. And if you put Wi-Fi, for example, in a mine, the range is limited. So you're going to have lots and lots of access points to even give the coverage. And then after that, once you go indoors and you're mostly outdoors, you can't sustain the throughput and the range. So private LTE network is ideally suited, for example, vehicles going in and out of the mine. They have these cameras mounted on them, and they want to stream data. So the private LTE network with a gigabit LTE, like I mentioned in our module, the LM960 can do up to 1.2 gigabits per second LTE data. And so you can deploy that in that setting. So that's why it ties in with ROI.
Perfect. Okay, so we have a whole ton of questions coming in. I'm going to move on to the next one, which is, will Wi-Fi compare with low latency private LTE network, private 5G networks? Sorry about that. And there are some other questions about how Wi-Fi stacks up to private LTE and private 5G. Robin, maybe you could address that?
Sure, yes. Well, as I said in my presentation, Wi-Fi has some distinct limitations when it comes to IoT applications, and those limitations become even more distinct on very large sites. And as we move more to broadband and specifically into real-time use and movement. Wi-Fi 6 is a clear development of Wi-Fi, and it's has some real benefits in it, but it doesn't really address the issues of industrial IoT applications. It's much more to do with use of Wi-Fi for administrative control in or office use in industry, and also, of course, for private use. So we would see Wi-Fi 6, Wi-Fi generally, and Wi-Fi 6 as being complementary to LTE for use in IoT applications. We think that it can be used to an extent, but it reaches a limit. And then LTE is going to be increasingly used beyond that limit. So we don't think that it replaces Wi-Fi. We don't think that LTE will replace Wi-Fi 6. We see them being used together and developing together. But LTE perhaps will have a faster growth rate than Wi-Fi.
Perfect. So I want to move on to another question. This one is about the outlook for network lifetime. So what is the outlook for network lifetime for private networks running on unlicensed bands? How about for chipsets?
Thanks, Matt. Probably one for Safi.
Sure, yes, good question. So the chipsets are not any different than the other chipsets. So the lifetime is no different than a commercial lifetime of other products. So typically, 5 to 10 year lifetime is very typical for these networks, but it can be extended because if you're doing a private LTE network and you plan to deploy it for a long period of time, then because the chipsets are not anything specially made for private LTE, the same chipset and module supply, you can enter into a long-term supply agreement with vendors. So there's no difference.
Great. So I'm seeing also a couple follow-up questions from people wondering about how exactly private LTE networks are structured. So this audience member asked, what structure are we talking about to operate Today, when we think of private LTE networks, we think of a huge core that is generally supplied by mobile operators. And another person asked, do private LTE networks on unlicensed spectrum require an MNO license?
Okay, I can take that as well.
Okay.
So yes, it's a scaled down version of the public network. So yes, it does have all the same components which are defined by 3GPP standard. So it's still LTE at the end of the day. It has to look and feel like an LTE network, which is a spec, a standard that it has to abide by. So it has to have all those components. The difference is that, yes, you don't have to support all of the large-scale area as well as the large number of users that a mobile network operator has to take into account. So in some ways, it's a scaled-down version of the same macro network. You can think of it as basically the small cells portion of the macro network carved into its own network, and then instead of the data going all the way back to a central core and coming back, the data stays local, and your EPC is implemented in a server right on your premises.
All right. So we have another question. This one is about devices. So, for example, for CBRS, do you know if device manufacturers will produce devices that are compatible with the CBRS band or perhaps with other bands used for private LTE?
It's another one for Safi, I think.
Sure. So yes, that really depends on what market you're talking about and what vertical. So, there are partners and customers that we are talking to, and they are producing devices that support band 48, but they also are producing the products that support band 42 and 43, for example. So it just depends what region the product is going into. And so for North America, primarily, they want to support band 48.
Great. Robin, I think this one is one that you could tackle. So we have someone here who's wondering, they've heard a lot about edge processing, and they're wondering if that has a role to play in private LTE.
Oh, definitely, yes. So edge processing as part of IoT is now becoming very hot. There's lots of opportunities for using edge processing in IoT applications as they become more central, if you like, to operations. There's a low latency opportunity. There's opportunities for pre-processing as well, and so I think the benefits, if you like, of edge processing match very well with use of private LTE. So we are expecting that gateways and routers, for example, as being the local hotspot, if you like, for edge processing capabilities, will make great use of edge processing for private LTE. We see, even within a private LTE site, there are a number of different activities. So if you can imagine a trade show, for example, or any, I'm just trying to think of, so what, the Disney theme park, that type of thing. There's sort of restaurants, there's individual activities, and sort of security aspects and so forth. And each of those are activities in their own right and require probably broadband connections to them. And then there'll be a number of local devices that are there as well. The opportunity for use of edge processing as part of that is very great. So we see it as being a very important part of private networking as that moves forward, and the types of applications, particularly real-time applications, increases.
All right, great. Thank you guys so much for answering those questions. Thank you to our audience for engaging so much with us. It's been wonderful to see all your questions pouring in. Unfortunately, we are going to have to wrap things up as we are at the end of our hour. And just so you know, we will be making a replay available very shortly, so you'll have a chance to catch up, review all the slides, and get any content that you may have missed. So thank you for tuning in with us, and we hope to see you again very soon. Bye now.